Hi, my name is Dimitri, and in this video we'll continue our K3S Kubernetes Cluster Build Series in a fully automated way using Terragrunt. In this video we'll extend our existing infrastructure layer in a powerful and flexible way using the Amazon Web Services AWS Cloud. It will be modular, reusable, and ready for the provisioning and configuration of our Kubernetes cluster in further steps. You will learn how to set up VPC, networking, security, identity and access management, and integrate the AWS module in the Terragrunt project in a flexible and structured, clean way. The project will stay extendable and reusable for real-world production and staging environments and use cases. This project will also allow you to easily replace your cloud infrastructure provider by just changing a variable if needed. And of course, all of this will be available in a public GitHub repository. The link you will find in the description of the video. Hey, if you find this kind of content helpful, smash that like button, share it with your colleagues and friends, and make sure to subscribe. Don't forget to hit the bell button so you never miss any awesome content coming your way. Let's dive in. Okay, we are in our project for the K3S cluster, and let's continue by creating the new module for the AWS Cloud. And we will start by creating the variables file, which represents all the inputs we require for our module. And we will continue with the networking, which should create a VPC and a subnet for our K3S cluster. We need some more stuff for the networking. That's why we are going to create an internet gateway. We will define it and associate this internet gateway with the VPC. Also, we will create a route table which will contain a route which allows the access to the internet. And we will associate the subnet with the route, so our K3S nodes can access the internet and install some packages. For the communication between the nodes and between the user and the cluster, we have to define the security groups, which represent the firewall within the AWS cloud. For this, we will create some security groups. The first security group will allow the internal TCP and UDP traffic within the VPC. The second resource will allow the HTTPS traffic from the internet, so we can access our services through a default HTTPS port. Then we will have a egress K3S rule, which will allow the outbound traffic for the nodes to the internet. And we will have a separate group for the management protocols, which will allow the Kubernetes API port through TCP and also the SSH port, so we can then configure our nodes. Now let's continue by defining the resource for our server. First, we will start with the identity and access management stuff. We will define a server role, which will have a assume policy, which allows the role to assume within the service EC2. We will create a instance profile and attach this instance profile to the role. Then we also will attach a policy to the role, which represents the management by the AWS Systems Manager. So we can use the SSM to connect to our nodes. And after that, we will continue creating the server, the instance type and the availability zone, the subnet, and we will also create a public IPv4 address for the instance, so the instance can access the internet. We will define the security groups for the instance, and depending on whether we allow the management protocols for this instance, we will attach the security group to the instance. Then we will give the AWS instance the instance profile we created earlier. We also will specify the user data, which allows us to install some packages and configure the access through SSH when the server is starting and initializing. Then we will define some tags, which will contain the stage and the name, and we will configure the dependency. Then let's create the user data script, which will be executed on initializing the instance. And the user data script will install the Amazon SSM agent RPM package. It will start this service and configure the SSH public keys for the root user. Next, let's create the required resources for the worker layer or the worker nodes. For this, we will use the already implemented server resources and just copy the file and make some adjustments, replacing the server string with worker. Next, let's configure the AWS Provider for the Terraform module. Let's also configure the output, which will contain the server and the worker IPs, the internal and the public ones, and also the SSH user, which will be used to connect to the instances. Next, let's define the Terraform state for the Terraform module, but since the state is managed by Terragrunt, we can just keep it simple here and define the local backend with an empty configuration. The next is to configure the environment by configuring the infrastructure layer in our environment. For this, we will use the input cloud infrastructure provider variable, and depending on that, we will include the required module. For example, if we want the AWS provider, we will include the AWS infrastructure module. Otherwise, we will stick with the Hetzner module. To use the AWS module within our Terragrunt project, we have to define the instance types for the worker and the server nodes and also the amount of them. And we need to specify the region, the availability zone, and also the image, which will be used to spin up the instances. In our case, it's the Amazon Linux 2023 with the ARM64 architecture. Okay, now it's time to test the code. I will define my SSH public key for that. Okay, we applied and let's debug. We have some errors here. The first error relates to a typo through auto-completion. And the correct attribute is map public IP on launch. Let's fix that. The second error relates to the wrong definition of the route. We have to specify the route as a set of object. Let's fix that. We have another typo here. Let's fix that. Another typo through auto-completion. We need, of course, the AWS instance. Let's fix that. Okay, and here we need to specify the security group ID instead of the security group object. Let's fix this. Okay, that looks better. The resources are getting provisioned. And let's wait for that. And now we can try to access the instances via SSH. The first tries to access the instances via SSH failed because the user data script has not been executed yet. After it executes, we should be able to access the server via SSH with the root user using our SSH keys. Okay, we have Amazon Linux. Okay, now let's destroy everything so all the resources are not eating up money. And the destroying is completed. Okay, let's look at our project structure now. We have created a new module called AWS Infrastructure. We defined the variables we need for our infrastructure. We kept it simple. Set up a VPC, the required subnet. We configured the internet access by defining the internet gateway and the required route. Then we also configured the security groups in a structured way. We defined the user data. We defined a separate file for our server resource and also for our worker resources. And the provider and the output and the state files we just recycled as we did in the last series, building the Hetzner infrastructure module. And we are using this module from our environment in the infrastructure layer, from this file here. We source the module and all the configuration regarding the infrastructure layer is defined in the environments file. I mean, the configuration is reused from the environments file. Actually, the definition is here since we merged the settings from our environments file within the Terragrunt HCL file. And this allows us to reuse the configuration and keeps our code dry. With little tweaks like adding a new module and sourcing the required module based on the configuration in our environment, we can just replace our infrastructure provider, use the AWS, and if not, we just stick with Hetzner. This project allows you to additionally extend this infrastructure layer by defining modules. For example, we will define a on-premises module, which allows the definition of a local infrastructure, which we then use in our further automation to provision the K3S nodes and install the required packages. It's a very flexible setup and best practice to set your project in that way. If we think forward, we can define a production or a staging environment in our environments folder and just use the required layers, keeping the same structure and keeping all in the same project, which makes the handling of this kind of infrastructure as code projects really simple. Okay, that was it for this video, and don't forget to like the video, subscribe to the channel and hit that bell button to not miss any videos coming next. Thank you for your support. See you in the next one.